Okay, so we're just going to work on those properties of exponents. Part A, we have 81 to the 5/6 power times 81 to the negative 1/3 power. When you are multiplying the same base, keep your same base, and we add the exponents. So 5/6 plus a negative 1/3. If you're doing this by hand, you would get your common denominator. 5/6 plus a negative 2/6 is 3/6, which reduces to 1/2. Feel free to add that on your calculator. I just want to make sure you end up with a 1/2 power. And then 81 to the 1/2 power is the same thing as taking the square root of 81, simplifying to 9. All right, our next example, we have some stuff happening inside a parenthesis and that whole thing being raised to the 2/3 power. So I'll tell you guys, life is easier if you can simplify inside this big parenthesis first and then raise everything to the 2/3 power. So inside the parenthesis, we have an x times a y to the third divided by an x to the 1/2. So we are dividing the same base of x, so we're going to be able to simplify these x's. When you divide the same base of x, you keep your exponent, or you keep your base, and then you subtract your exponents, 1 minus a half. Well, sometimes these fraction exponents you can do in your head. 1 minus a half is a half. And then the y to the third didn't change. So basically, we just simplified inside the parenthesis, so it's a little bit easier now to raise this product to the 2/3 power. So we're going to break this up. This x to the 1/2 power gets raised to the 2/3, and this y to the third power gets raised to the 2/3 power. Now, this is that power to a power. You keep your base of x, and we are going to multiply exponents. So 1/2 times 2/3 is 2/6. 2/6 reduces to 1/3. And then here we have y to the third power times 2/3. That's y to the 6/3 power, which reduces to a y squared. So we've got x to the 1/3. Here, maybe I should say these are all equal. And then that x to the 1/3 power we can write in radical notation. So we can bring the y squared out front and then recognize that's taking the cube root of x for our final answer.